Okay, so this will be the third video. I'll just do one more problem, and then at the end of this video I'll tell you what problem you should do tonight before you come to school tomorrow. Alright, so problems 1 through 8 on page 322. It says oral exercises, but if you flip over to 324, you'll see that the first 8 in the problem section tell you to go back and solve the oral exercises ones, which you were actually just setting up. Since all the charts are done for you there and everything else is just kind of plugging stuff in, I'm going to leave that for you guys to work on tomorrow. Instead, I'm going to work on problem number 9 on page 324. Okay, so once again we have we have page 324, and we're going to do number 9. So let's read that. It says, how many liters of water must be added to 50 liters of a 30% acid solution in order to produce a 20% acid solution? Okay. Once again, organization is key here. Bring out the chart, same chart. It's very similar. You can probably figure it out. You can pause, figure out which headings to use. You can look back on page 322, 323, and try to make out your chart and see if it is the same as the one I'm going to make here. So, how many liters of water must be added? Okay, so we're talking about liters of added to a solution. So, amount of solution, and we're talking about liters. We're going to multiply that times a percent of, looks like we're talking about acid, and that's going to equal total acid. Okay, very important to have the headings down there. Having a chart without headings, it's like not very helpful at all. You might as well not even make the chart. On the left side, so we're starting with an acid solution. Okay, so you can say original solution, you can write solution, okay, and then we are going to add water. So added water, and then we're going to get a new solution after we add water to the old solution. Okay, now we have the headings. Once again, everything just kind of falls nicely into place as we read. So I'm going to reread it again. How many liters of water must be added? Well, right there it's telling me how many liters of water must be added. That's the question. How much added water? Well, let's figure it out. That's going to be our variable. We're going to add to a 50-liter solution. So it starts as a 50-liter solution. Actually, I don't need the L there. I'm just going to put 50. We'll deal with that in step 5 when we actually answer the question. The original solution, they said, is 30% acid. Okay, so we're going to put 0.3 here. Again, when we add water to something, hopefully there's no acid in your water, or else you're going to have a real bad day. And we're going to produce a 20% solution. So that new solution is going to be 20% because we're making it. And again, the solution, when you add water to it, you add some amount of water. Once again, the right column is the multiplication of the two columns that we're starting with. That middle one with the 0, obviously 0, there's going to be 0 acid in the water you add, so we can just write it like that. And here we go. So the total acid in the original solution plus the total acid that we are adding, which is nothing, should equal the total acid in the new solution. Okay. So we're going to solve this. One thing you might think about doing first is multiplying everything by 10. With the way that I've set it up. The decimal is inside the parentheses here, outside the parentheses here. It might seem a little awkward, but what happens is when you multiply this whole side by, looks like 10 should be enough, and this side by 10, I'll just kind of put it right there. It only affects each term, okay? So 50 times 0.3 is one term, so we only have to affect one of these things. So when you multiply it by 10, it just becomes 50 times 3. The 0 obviously remains a 0, but I'm going to leave it out entirely because we don't need it anymore. And the 10, again, now this 0.2 with the parentheses 50 plus x, all of that is one term, right? Because this 0.2 is going to distribute to everything inside eventually. So if we just multiply the 10 by the 0.2 and get 2, then it's going to, in the next step, affect that 50 plus x anyway. So you don't want to do it in this step and then again in the next step, because then you've done it twice. So we don't want to do that. So now we have 150 equaling 100 plus 2x. This is nice. It doesn't look too difficult of calculation here. We're subtracting 100 from both sides to get this. And we're going to divide both sides by 2. Hopefully we get the right answer here. But when we check our answer to see if it makes sense, that should be good as well. So let's see. We think that we're going to, I don't remember what x is, so I'm going to go up to my chart. Okay, x is added water. So we think we should add 25 liters of water. So let's double check. Yeah, so I think I'm going to add 25 liters of water. That's what I'm going to write down as my answer. However, what I could also do is see if that makes sense mentally. Okay, so I'm going to look back here. If we had 50 liters of a solution that was 30% acid, would it make sense that if that solution was now 75 liters, okay, that the same amount of acid would be 20%? Okay, so remember, 30% of 50 would be 15 liters of acid in that original solution. Okay, our new solution is 75 liters, but it's only 20%. 20% of 75 is 15. So we did a little mental calculation, and we have determined that our answer makes a lot of sense. I highly recommend doing that every time you finish a word problem. Does my answer make sense? Very important question. Okay, so for your homework, what I want you to do, one measly problem, that's all, after listening to all these videos. Problem number 10 on page 324. Problem 10 on page 324. You must use the 5-step method, meaning every single step that I've shown in these problems you need to do. You need to have your chart. You need to have your headings. You need to fill in the chart. You need to make your equation, solve your equation, and answer the question. Okay? And then you'll be finished. Thank you, and have a good night.